All right, so let's get started. Today we're going to be talking about unit conversions. Before we kind of dive into there, I just want to sort of take 1 second to note what this way that we're going to be formatting certain numbers today, what we call scientific notation. Okay. I'm not going to go too exhaustive on this. I have a feeling that most people are very familiar with it. If you are not, just this is the name of it. YouTube it in like 5 minutes. It'll be a thorough explanation. All right, but this is a way that we represent either very small or very large numbers more conveniently. So for example, if I had, we'll do a different example than what we did last time. 7,600. This would be our normal, what we would call standard notation. Okay. We could represent this in a more compact way using scientific notation, where we say 7.6 times 10 to the third. All right, and if you punch that into your calculator, you would get 7,600. Right, 77.6 times 10 to the third times 1,000 gives you that same value. So importantly, we're not changing the value of this number at all, right? We're just representing it in a different way, what we call scientific notation. Okay, proper scientific notation always has one number in the ones place, followed by a decimal point, and however many significant figures you have on the end there, right? So however many digits are displayed depends on how many sig figs that number has. But we always just have one digit to the left of that decimal place in proper scientific notation, okay? So we're going to be using this to represent very big numbers and very small numbers, all right? Really what we're going to move on here is to talk about our metric system and the metric prefixes. All right. So in our American system, we represent distances, for example, that are very small, like the size of my iPad. We would represent in inches. That would be the convenient unit for that. But if I'm talking about the distance from here to my house, I'm not going to talk about it in inches. That's not a very convenient unit to use because it's so tiny. I would talk about it in miles, right? So that's how we kind of scale based on size in the American system. In the metric system, they scale their units based on size in that same way. They want to talk about small stuff in a convenient unit and large stuff in a more convenient unit, but they do so by changing the prefix on those measurements, okay? So for example, I think if everybody's heard of centimeters, right? I could measure the size of my iPad in centimeters as well. If I was going to talk about the distance from here to my house, I wouldn't want to do so in centimeters. I would use kilometers or kilometers, where I've just changed that prefix on the front of that meter measurement from centi to kilo. So that's how they kind of scale things in the metric system. And we want to be able to convert in and out of these different prefixes here, okay? So first of all, if I took a number like 7,600, and we're going to put some units on that. Let's say that we're talking about meters. As we said, this is the same thing as our 7.6 times 10 to the 3. Again, putting some units on that, meters. Well, we could represent this more conveniently by changing the prefix out front here. That kilo prefix that I was talking about represents 10 to the 3. It means multiply those units by 1,000. So this would be the same thing as 7.6 kilometers. Okay, so how do I know that? How do we convert in and out of these metric prefixes? We're going to use this constants page a lot today. Okay, so this constants page you can find embedded in your homework where you need to be using it. You download it on the entry page there. It's also posted on Canvas under the course under the introduction page of this Chapter 1 module. Right, that very first page under the Chapter 1 module contains all of our learning objectives, as well as any documents that you might need, so this constants page, for example. Okay? And specifically what we're going to focus on right now is this part. This is our different metric prefixes that we can use here. And like I said in my example, that K, that kilo prefix, represents 10 to the 3. Okay? And some of these might be familiar. You might have heard of a kilo or a centi before, and other ones might not be familiar. All right? Nano, for example, is a really popular one that we use to describe stuff that is super teeny tiny. Femto is then even smaller, right? So we have these different prefixes, and we want to be able to convert in and out of them. Okay? So how do we do this? We're going to do this game that we're going to play a lot today. All right? What we're going to find is everything that we do today falls, and really a lot of what we do in this course math-wise, falls under this umbrella of what's called dimensional analysis, where basically we need to pay very careful attention to the units when we're doing our math. So what you'll see is in my examples up here, I never just have like a naked number that I'm doing math to. I'm always including the units as well. And you want to do that in your notes. You don't want to get lazy and just do the numbers, just do the math part. It will make sense to you in that moment for like 5 minutes. And then you're going to go a week from now and flip back in your notes, and you're going to be staring at a page of numbers. And it's not going to make a damn sense of what's going on there, right? So put your units down. Make sure you're following along just like I do up here with your units, because how we set up these problems is going to depend 100% on those units, okay? So what we're going to do is we're going to take this right here, and we're going to build what we call a conversion factor, something that's going to help us convert from one set of units to the other, okay? So let's take that kilo entry here. All right, how do I convert this information, rather, how do I put this information into a conversion factor? And we're going to do that exact example that I just did, where we do 7,600 meters into kilometers. That's our goal, converting from one to the other, okay? So this entry right here in this table, we're going to build what we call a conversion factor. And a conversion factor is always a ratio. I'm going to have one number up top with the units and another number on the bottom with units. This is what our conversion factor looks like here. Okay? So my entry here is telling me that 1 kilometer is equal to 10 to the 3 meters. Right? Likewise, 1 kilogram is equal to 10 to the 3 grams. 1 kilosecond is equal to 10 to the 3 seconds, et cetera, all right? What unit I use back here depends on what I'm measuring. In this case, I'm talking about distance. If I was talking about mass or time, it'd be different, all right? What we're changing is the prefix out here, going from this kilo prefix to no prefix at all, okay? Now, looking at this table here, it's kind of easy to accidentally flip these numbers, to accidentally put the 10 to the 3 with the kilometer and the 1 on the bottom, all right? So what we're going to have is this like little phrase that we're going to keep in mind with these metric prefix conversion factors that are going to make sure that we set it up correctly, is that the 1 goes with the prefix. All right, this is this little thing that you're going to chant to yourself when you're setting this up to make sure it's done correctly. When I'm looking on my table here, the 1 is with that kilo prefix. I look on my table, kilo has this number. The 1 on my conversion factor goes with the prefix. The 10 to the whatever goes with just the unit by itself. Okay, so real quick before we move on here, I want everybody to take a second and to build me a conversion factor with micro. Okay, using the same logic. Let's say micrograms. Change it up just for fun here. Just going to make some room here. All right. If I was going to play the same game with the micro entry on this table here, I have this 10 to the 6. All right. So first of all, my conversion factor would be from micrograms to grams. I'm going to need to use this 10 to the negative 6. I'm going to need to use this 10 to the negative 6. All right. But does it go on the top or does it go on the bottom? On the bottom, right? Because I'm going to put a 1 in front of the prefix. So then the 10 to the whatever goes with the unit with no prefix at all. Okay? Okay, cool. So this is how we build our conversion factor from this table here. Again, it's kind of easy to mix these up. So remember this little phrase, the 1's going to go with the prefix. Okay? All right. Let's just get rid of this. Let's focus here. So when we use these conversion factors, we're going to be multiplying or dividing by them in such a way that our units are going to cancel out. All right? So in order to do that, for every conversion factor, we could either multiply it or divide it by that conversion factor. If we multiply it, we would just use it as is. If we divide it, that's the same thing as flipping our conversion factor upside down. So every conversion factor, we could use one of two ways. One, the way that you build it first, or you could take it and flip it upside down, meaning I'm going to put 10 to the 3 meters on top and 1 kilometer on the bottom. Every conversion factor that we build, you can use it as is or divide by it, aka flip it. All right? And what you're going to do is dependent on the units. So in this problem here, we're starting out with that 7600 meters. I'm trying to get rid of meters and end up in kilometers, right? So I'm trying to cancel out that unit of meters. So what I'm going to do is I'm going to pick my one of my two conversion factors. I got two choices here. I'm going to pick the one that has meters on the bottom so that it cancels out when I do my math here, all right? So what do I mean by that? Let's multiply by this conversion factor on the left, 1 kilometer, 10 to the 3 meters. And before I even do any math, before I punch this into my calculator, I can tell that this is set up correctly because meters are on the top, meters are on the bottom, which means that they cancel out, right? Anything divided by itself is just 1. So those two have now canceled out, and I'm left with units of kilometers here. Okay? So if we punch this into our calculator, we get 7.6. And again, paying attention to my units, my meters have canceled out, leaving me in units of kilometers. Okay? Now, we have to do our sig figs as well. All right? In this case, my calculator actually did fine, did a good job. But we're always going to double check our sig figs here. We always have to pay attention to what we're multiplying, right? Remember those rules for carrying sig figs. We got to check the sig figs in everything we're multiplying, and then we got to pick whichever is fewer. All right? So how many sig figs are in this 7,600? 2, because those trailing zeros don't count, right? So this has 2 sig figs. Our metric prefix conversions are an example of these exact conversions. Remember we talked about exact numbers as if they have an infinite number of significant figures, okay? That's because these metric prefix conversions are defined that way. It's not like sometimes a kilometer is 10 to the 2 and sometimes it's 10 to the 4. No. A kilometer is defined as 10 to the 3 meters. That's the definition of what a kilometer is. So these conversion factors, and many of them on this table here, but we can just note, it says it up here, are all exact, meaning they have an infinite number of sig figs, which just simply means, kind of conveniently, we get to ignore it when we're doing our sig figs, right? That's never going to limit our sig figs, an exact number. So this one has 2 sig figs, this one is exact, which means my answer should have those 2 sig figs, so I'm good with 7.6 kilometers. Okay? All right, so we're going to take that micro conversion factor that you built, 1 micro, what did I say, gram? 1 microgram is 10 to the negative 6 grams. All right, we could take this or we could flip it. So we're going to need to use that or 10 to the negative 6 grams over 1 microgram. Let me just make it extra special clear here. I didn't just flip the numbers or just flip the unit. I flipped the whole thing, right? 1 microgram on top, 1 microgram on bottom. 10 to the 6 grams on the bottom, 10 to the negative 6 grams on the bottom, 10 to the negative 6 grams on top. You flip the whole thing. If you just flip the numbers or just flip the units, you would mess up your conversion factor, okay? So just to be clear. Okay, so now everybody's going to take a second. And given this logic that we just laid out here, I want you to convert from 0.00042 micrograms, I lied, grams, that would be really tiny, into micrograms. All right, so I'm going to start with what's given here. I'm trying to cancel out those units of, I'm going to multiply by one of my conversion factors. I'm trying to cancel out those units of grams. So which one of these two conversion factors am I going to use? The one on the left or the one on the right?
The left.
The one on the left, because that has grams on the bottom, which is what I'm trying to cancel out here. All right, so now I'm going to multiply by 1 microgram is 10 to the negative 6 grams. Okay, we can punch that into our calculator. Our calculator spits out 420. We always have these 3 steps. 1, just do the math. Punch it into your calculator. 2, our numbers are never naked. They're going to have units. All right, so now let's do our units. And again, I know that this is set up correctly if my grams cancel out and I'm left with those units of micrograms. And then because this is a super fun chemistry course, we also have this very last step where we got to do our sig figs. All right? And how many significant figures should my answer have? 3. These leading zeros never count, but this 0 at the end does count because of that decimal point, right? So trailing zeros count if there's a decimal in that number. So this does indeed have these 1, 2, 3 sig figs. How many sig figs does this number have as I've represented it here?
2.
Just 2. So I have to put that decimal point at the end there in order to indicate that last 0 is significant. All right, cool. All right, so then one more. Let's go up to this table here. I want you to do it from scratch. Make some room here. You're going to convert, let's do 4,620 milliseconds into seconds. All right, step 1, you're going to build that conversion factor. All right, so my conversion factor here is from seconds and milliseconds. I'm relating these two units here. Where's the 1 going to go, on the top or on the bottom as I've written it here? The 1 goes with the prefix, all right? I tried to be tricky. I put it upside down to what I did the first time. The 1 goes with the prefix, all right? So 10 to the negative goes on top. And I could, of course, have taken this and flipped it upside down. Either one of those, right? Okay, now we're going to set it up to cancel our units. So I start with my 4620 milliseconds, and I'm going to pick the conversion factor here that will allow me to cancel those units out, right? So that means I'm going to pick the one with milliseconds on the bottom and my 10 to the negative 3 seconds up top. All right, so now I have to divide by that milliseconds. This cancels out, leaving me with units of seconds. I punch this into my calculator. I get 4.62, my units being seconds. How many sig figs should my answer have? 3, so I'm good. Cool? All right, so step 1, build the conversion factor. Step 2, our units. All right, step 3, we'll say do the math, include units, and sig figs. All right, that's how we're going to do our unit conversions. Now, obviously, when you get good at this, you're probably going to skip the step of writing down these conversion factors every single time, right? And that's great. Let me just say, though, if you do get stuck, especially on these problems that have more and more steps, putting your conversion factors down so that you can see what units you have to work with can be a really helpful step to kind of get unstuck, right? So when you're good at this, great. Go ahead and shortcut it all you want as you're getting better and better at it. But if you do run into a wall at any point, putting down what you think you're going to be using, these conversion factors that you think you're going to be using, can be helpful to figuring out like the little puzzle, the little path that you need in order to get from A to B. Okay? All right, so then the last one we're going to do, we're going to kick it up a notch here. Now I want you to take me from, let's do 4.70 times 10 to the negative 6. We're going to go from kiloliters to milliliters. And what you're going to need, let me just give you like the punchline here, see if you guys can figure it out. What you're going to need is not 1, but now 2 conversion factors from that table. You're going to have to build one that takes you from kiloliters to just regular old liters. And then you're going to have to use another one that takes you from regular old liters into milliliters. All right, so in terms of our math, what we're going to do is we got to find this path using our conversion factor. We're going to go from kiloliters to liters, and then from liters into milliliters. That's how we're going to do this multi-step conversion here, this double jump conversion. Okay, so I'm going to give you all a second, see if you can figure it out, and then we'll do it together. All right, so I'm going to go 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. Hold on a second. Let me move this over. 4.70 times 10 to the negative 6 kiloliters. I'm going to run out of room here. 4.70 times 10 to the negative 6 kiloliters. I'm going to use that conversion factor where I have kiloliters on the bottom and liters on the top. Again, the 1 goes with the prefix, and kilo, according to my table here, is 10 to the 3. So there are 10 to the 3, 1,000 liters in a kiloliter. Right? And now I need to make a jump from liters. So if I stopped here, to be clear, my units would be liters, right? If I just stop my calculation here. Kiloliters cancel out, I'm left in units of liters. But now I need to make another jump from liters into milliliters. So I'm going to multiply by a conversion factor, now with liters on the bottom and milliliters on the top. All right? Again, the 1 goes with the prefix, and according to my table here, milli is 10 to the negative 3. Okay? If I punch this into my calculator, so we got it all lined up. We're going to do the math. Punch it into our calculator. Calculator spits out 4.7. Our units, again, this is like the satisfying part of this dimensional analysis. We go through, we get to cancel our liters, our kiloliters, cancel our liters, and we're left with the units that we want. We're left with milliliters. And then that last step, what's our last step? We do the math. We do our units. What's the last step? Sig figs. All right, how many sig figs should my answer have? 3. Nice thing about scientific notation is that all the digits that you display are necessarily significant, right? Just by the definition of scientific notation, having that decimal point in there. So I know all my digits that are displayed are significant here. So I got to include that 0 on the end there as well. All right, so 4.70 milliliters. Cool? All right, this whole unit cancel, set it up so that your units cancel out business. We are going to play that game over and over and over again this semester. That's like the only game we're going to play, all right? So make sure that when you're doing your notes, when you're doing your homework and stuff like that, you're paying careful attention to the units. It's all about the units, all right? That's how we know that our math is set up correctly. Okay, so now let's introduce ourselves to the rest of this page here. All this other crap we got going on. This specific box over here that we've been working with converts in and out of these different metric prefixes. All right. This other part of this table, and actually we're going to exclude this box here. We'll get to that in the next chapter, but this box up here we won't use quite yet. Everything else over here on the left-hand side is a unit conversion factor. All right, so let's just kind of zoom in to one that I think we know. Our entry here, 1 foot, gives us the abbreviation for feet and tells us that that is equal to 12 inches. All right, we all know 12 inches are in a foot, right? So that's what this table is telling us. 1 foot has 12 inches. All right, so from this table, we could represent this information in one of 2 ways. All right, we could say that 1 foot equals 12 inches, but that's not going to be the really helpful way to do it. All right, we're again trying to do these unit conversions, so we need to build our conversion factors. So we're not going to set them equal to one another. We're going to take one and stack it on top of the other one. All right, so this tells me that 1 foot is equal 1 foot over 12 inches, and I can take it as is, or with our other, just like our other conversion factors, we can flip it. All right, so that entry on my table here is how I built my conversion factors. And just like we were converting between these metric prefixes, you're going to play that same game that we just did. But what you're going to do for me is you're going to tell me if I have 42 inches, how many feet is that? Use this conversion factor here. right, we take our 42 inches. We're going to multiply by one of these two conversion factors. Am I going to pick the one on the left or the one on the right? I want inches on the bottom so that they cancel out. So 12 inches, 1 foot. Punch this into my calculator. I get 3.5. What are my units? Feet. And my sig figs, I should have 2. Oh, let me just note, my sig figs, I should have 2. If we're gonna, let's do this the long way real quick. This has 2 sig figs, my initial measurement of 42 inches. My conversion factor, though, is exact. Everything on this table here that has these 2 asterisks next to them are an exact conversion. So it's not like sometimes a foot is 11 inches and sometimes it's 13 inches. A foot is defined as exactly 12 inches. Okay? So just like before, this is yet another exact conversion factor, meaning it's not going to limit my sig figs. The vast majority, not all of them, but the vast majority of our conversion factors are indeed exact. They're based on definitions. There are some that you got to watch out for, right? Notably converting from grams to ounces or from pounds to grams here. Those do not have those asterisks and would not be considered exact. Cool. All right, so just like before, we're going to take this information from this table and we're going to build a conversion factor where we stack one set of units over the other. That helps us convert. And when we're doing our math, we can use them as is, or we can take them and flip them upside down, right? And what we're going to use is going to be dependent on the problem, what units we're trying to cancel out. Cool? All right. So let's do another one here. I want you guys to do this from scratch. Okay, let's again take our, let's take our 42 inches, but you're going to convert that into centimeters for me. All right, so we go to our table here. We have to find the entry that's relating these two units here. So that'd be this one here. 1 inch is 2.54 centimeters. And I take that and I build my conversion factor, 1 inch over 2.54 centimeters. Or I could flip it upside down, 2.54 centimeters on top, 1 inch on the bottom. I'm starting out with my 42 inches. This is my measurement I'm trying to convert. And I'm going to use which one of these two conversion factors here, the one on the left or the one on the right? Now I'm going to use the one on the right so that my inches cancel out. I'm going to need those units of inches on the bottom and centimeters on the top. 1 inch equals 2.54 centimeters according to my table here. I punch that into my calculator. I get 106.68. My units, inches cancel out. I'm left with units of centimeters. And then finally, I have to do my sig figs. How many sig figs should I have in this answer? So my input here has 2 sig figs. This is another exact conversion. So I'm going to round this to 2 sig figs. So my final answer here would be 110 centimeters. No decimal place on there because I don't want to indicate that that 0 is significant. Cool. And so let me just note how this table's kind of formatted. It's based on what quantity is being measured. So all of our distance measurements are found up here in this first block. If I'm talking about measuring volume, those conversion factors are now in this next block. And then mass. We also have quantities that we haven't even quite talked about yet. Energy and pressure, all right? We talked a little bit about temperature, and then here are these two miscellaneous ones. Coulombs are used to measure electricity, and newtons are used to measure force. If we needed to convert, look, we could convert between leprechauns and triangles if it was on this table here, all right? So even if we've never heard of these units before, we're looking for the entry that relates them, and we can convert from one to the other, all right? So now lastly, we need to do the same game that we played before, where we're going to do these compound jumps, these sort of multiple jumps in our unit conversions. All right, so what do I mean by that? I'm going to stick to distance here just because it's conveniently at the top of this table. All right, let's say that I had 0.00340 feet, and I wanted to convert that into centimeters. All right, I'm going to look at my table here, and I'm going to fall into a little bit of a problem, which is that there's no one entry that takes me from feet into centimeters. All right, instead, I have this entry that tells me that 1 foot is 12 inches. So I can go from feet to inches. I got to find my little path. Oh, I get it. From feet into inches. And then I'm going to have to use another conversion factor, this one here, that will take me from inches into centimeters. All right, so we have to find a path through our units here that takes us from one to the other. If we can't find just one entry, we're going to have to link up multiple entries. All right, so everybody take a second and do this conversion for me. All right, so starting out with my 0.00340 feet, I'm going to need to multiply this by this conversion factor that takes me from feet into inches. According to my table here, 1 foot is equal to 12 inches. And then I'm going to do another jump that takes me from inches to centimeters. Again, looking for that entry on my table here, we got 1 inch equals 2.54 centimeters. So I'm going to take my 0.00340, punch it into the calculator where I multiply by 12, divide it by 1, you can skip that step, multiply it by 2.54, and I get 0.1036. Again, units going back, my feet cancel out. Foot on top, foot on the bottom, those will cancel. Inch on top, inch on bottom, those cancel. And I'm left with those units of centimeters. I got to do my final step here. How many sig figs should be in my final answer? 3. Cool. So My initial input has 3, and since both of these, according to my table, are exact, they're not going to limit me, right? I know this 12 looks like it has 2 sig figs, but given that it's a definition, it's an exact conversion, it will not limit us. So my final answer here should have these 3 sig figs. So 0.104 centimeters, put a box around it. Doesn't matter. Okay, and actually this is real quick, this is a good point. Let me just bring up, first of all, many of your calculators, especially the older ones, but also our online homework system, when they're doing scientific notation, instead of doing times 10 to they use this capital E, okay? And so let me just real quick, let's say that I had our 0.104, what did we just do? Centimeters. I could also do this in scientific notation as 1.04 times 10 to the negative 1 centimeters. Those are the same number, all right? And if I were going to do this on a calculator that has this E format, or our online homework system, whatever it is that has this E format, it would be 1.04 capital E negative 1, where the E stands for times 10 to the. Okay? So you can use this, you can use either standard notation or scientific notation in your homework. There are some that are picky and it specifically says what notation to use. All right, but generally speaking, you could use either, whichever more convenient for you, but you'll use this E here. What's up?
Just to confirm, whenever you go to scientific
Centimeters.
notation,
Yeah.
it's always the first digit is going to be before the decimal.
Correct. Only one digit before the decimal. Between 1 and 9. Okay. Yep. So importantly, I can't say 10.4 times, it would actually be times 10 to the 0, but whatever. Times 10 to the negative 2. You don't have 2 digits before the decimal. This would not be considered proper scientific notation. Cool. All right, so where are we at here? Punchline of today. We learned how to use this constants page here, right? And what we do is we build these conversion factors. These conversion factors allow us to jump from one set of units into another. We first talked about jumping between these different metric prefixes. This is how we can scale these different units of measure by changing the prefix. So we would, again, use a different prefix to talk about things that are very small than we would use to talk about things that are very big, all right? But also we can convert between our different units that we use for distance, volume, mass, and even energy and pressure by using this constants page here, right? Where we grab this entry and build our conversion factor. Every conversion factor you could take or flip upside down depending on what you need to do with your units. What's up?
Now, how much of this are you wanting us to commit to memory?
None of it.
Okay, will this be like on?
This is, 100% this exact same thing is what you can expect to see on your exam. So anything I call a constants page means that you can expect to have that on your exam as well. So yes, absolutely none of this. I mean, for your own sake, I will say kilo and milli are just really important to have a good grasp of. That gets used really quick and fast and loose, but I'm not going to not provide you with this table ever.
Well, it depends on what you're going into too. Like if you're going into pharmacy, you know.
Yeah, I mean, they just use it real quick, and they kind of expect you to be able to do those too. But yes, no, you don't have to memorize any of this for
We
me.
used picodoses and VetMed, and that was super fun.
Okay.
Like, yeah, tiny kidneys.
Yeah, I bet. Those are super tiny. Cool. All right, man. Have a good one. Have a good weekend. Yeah, okay. Say it again, sorry. Do you need to? Yes. Yeah. The 23rd? Yep, sure is.